I'm just walking through how to convert this rotary screw compressor. It's a 7.5 kilowatt unit. It's also pretty big. I think that's a 500 litre tank. And over there is the refrigerant dryer that goes with it, oil cooler as far as I've been able to tell. And problem with this is that the start current on the motor is so high that it blows the fuses in my workshop. So with a 7.5 kilowatt motor, I calculated, assuming a power factor of 0.8, and the motor's back here. The motor is enormous. Let's see if we can see most of the motor details. But the motor is huge. Here's the actual compressor unit. Might get a better angle from this side. Yep. And the intake up here. Normally this is all enclosed with sheet metal, which I've all removed here. The side panel, the front panel, and back here is the rear panel, which is huge. And I've just been going through this to trying to find out what I can do with it. So it seems like it runs anti-clockwise direction, and we have an ES3000 controller, which is pretty normal. And I think that the plan of campaign is going to be to use a 3-phase to 3-phase frequency converter and remove these star delta starters that we have down here. I've been looking at how the cabinet is put together, and it has this intermediate shelf in, just I think to leave a little bit of, can't be cooling room or anything up here, it's just nothing. So I think what I'll do is I'll remove the shelf just by drilling out the rivets. I've checked that the dust seal will be able to be added around here instead. Can't do this one-handed. And then I need to find some dust seal with this kind of profile, just to extend down here. So with the dust seal out of the way, I've been tracing where the power comes through this machine. It comes in here through the main power cable. Let's get rid of the dust seal up there. It comes in here, comes all the way up, passes through the main isolator, and then these 3 individual circuits, they all come 22, 21, 23, they all come then down here, out of here, through some ceramic fuses, and then back into whatever this unit here is, which I haven't figured out yet. So we'll look into what that is exactly. That takes all of the connections into here, and then they seem to split up a little. So I do have the wiring diagram here. It's been coated in compressor oil, so it looks very antique. But we'll get the wiring diagram out. And we'll just be able to work through all of the parts of this. Now the plan is to replace the star delta starter with 3-phase to 3-phase VFD, so I can control the start current, and then to use the ES3000 controller to activate not the contactors that are for the star delta starter, but to interrupt those connections here, connect them straight into the VFD, and then simplify the motor wiring here. So the motor wiring is quite simple. If you trace out of here, so this L, T and Y, I think Y is to do with the controller, T is to do with the motor, and the L I think is the motor starter. I have to dig into this a bit more, but anyway, I have 6 wires going through this cable canal into the motor. And typically in star delta motors you would find all 6 of those wires running into the motor control panel. And so this must be a dual voltage motor. That's why it has 6 wires. But the start current is on the order of 160 amps, or anyway between 70 and 160 amps, assuming a power factor of 0.8 from the calculations that I did. So I'll make this the first video just to give an introduction. I think the second video will be mounting, removing the shelf and mounting the VFD. I'll also talk about why I selected the VFD that I did. I have another VFD on my milling machine over there, and that VFD is actually a 220 volt VFD that simulates 3-phase. And for a little 1.5 kilowatt mill, that's fine. But yeah, in here I think ultimately this and this will go away. Or I'll try to maybe keep them and isolate everything safely in case I do ever need to return this to normal. Remove the shelf, heighten it, rivet it back in again, and that will give me space here for the VFD. And the VFD has a remote control panel, and I'll bring that remote control panel out here as well. Maybe somewhere here I have a 1/2 meter extension for that, so plenty of room from somewhere here to the door here. Yeah, and all things being equal, I should be able to replace this beast of a compressor, which is extraordinarily noisy. 5.5 kilowatts, I'm not sure. 270 litre tank, and hopefully be able to replace this. There you go, 97 decibels. This one has an operating volume of something like 68 decibels when it's all up and running. So yeah, I'll stop this video here, and maybe in the next video we'll talk specifically about what wiring I'm removing, how to make sure that everything is safe. Do all of this, of course, at your own risk. And then at some point I will need to figure out which one of these outputs. Yeah, here, remote controls. So in there it may be RS245 connection that I have to deal with if there's no... Yeah, not sure. We'll look into what that means up here. But my hope is that we won't destroy the original Siemens industrial control stuff here, and that we'll just be able to integrate this thing in a more or less reversible way, in case anybody ever wants to put this compressor back to normal. Thanks a lot.